Okay, now let's see the factor affecting rates of duration. There are 4 factors that will affect the rate of duration. Is it the rate will be faster or the rate will be slower? Number 1, when it involves temperature. I will explain one by one after this. Right, and number 2 is increase in concentration of dissolved reactant and decrease of pressure. So concentration and pressure, they are related much to each other. And then number 3 is increase the surface area. What will happen to the rate? The surface area increase. And then the use of catalyst. How catalysts play a role in increasing the rate or decreasing the rate of reaction. As we know, when we increase the temperature of a substance, basically what happens inside the reaction, okay, particles become having more energy. So when they have more energy, they will tend to move faster. Okay, they will move faster, and then what happens? They will collide to each other particles. So when the particle collide, okay, they do so with the more energy, so more number of successful collision will be increased. Thus, the faster the reaction will be. Okay, so once you increase the temperature, particle will have more energy, they will move faster, they will collide to each other. So basically, they will more increase the successful of collision will be increased. So the rate of reaction will be faster. Okay, concentration, okay, the same thing. When you increase the concentration in a dissolved reactant, the faster the rate of reaction will be. Alright, so once you have higher concentration, this is just imagine these two figures. Once you have lower concentration, one with higher concentration. So once you have more higher concentration, meaning that you have more particles inside the space. So when you have more particles inside the space, collision between each other will be more likely compared to the one that have lower concentration. They will collide more compared to the one that having a little concentration. Alright, so they will collide more. So once they will collide more, what happens with collision? Successful will be happen. So thus they will increase the rate of reaction as well. Pressure, okay, compared to the pressure, the same thing when you have lower pressure and higher pressure compared to this figure. Alright, so higher pressure basically it will increase the rate of reaction as well, because the space in which gas particles are moving is become smaller. So that means that they are close together. So this is will increase the frequency of the collision. They will collide more compared to this one, which is will be lesser collision happen. So this means that particles are more likely ready to react, so they will produce more rate of reaction. Surface area, okay, in any reaction involve a solid can take place in surface of the solid. But just imagine if this one you have one bulk of box, for example, it's going to give you a low surface area because it's just one space. But if you chunk the box or the substance into few particles, okay, it gives you more surface area. For example, there will be more surface that we touch, okay, to the reactant particle. Okay, when we chunk into smaller part, we got more higher surface area. Okay, the smaller the pieces, the larger the surface area will be. This means that more collision, they will collide to each other faster and more greater chance for the reaction to happen. So means that in the end the rate of reaction will be increased simultaneously. Right, catalysts. How do catalysts play a role? As we know that catalysts, a substance that change the rate of the reaction without it itself being used up. Okay, so catalyst function of the catalyst is to speed up the reaction without itself being consumed in the process. Okay, catalyst somehow it never produce more product. They just produce the same amount more quickly. Okay, just happen to increase the reaction more speedy. Alright, so different catalysts works in different ways, but more slower. You're going to lower the activation energy, and thus it helps the rate of reaction will become faster. Okay. Alright, so in order to understand all those factors that affecting the rate of reaction, you must understand first the frequency of the collision, or is will represented by E. Okay, in order for the reaction to molecule to react, they must collide. I mentioned many times, it must collide first. When it's collide, you must increase the number of collision. So if you have more number of collision increase, means that the rate will be higher, successful, it will be more increased. So the collision theory is saying that the reaction molecule must collide with one another. Then the reaction molecule must collide with sufficient energy. If you have less sufficient energy, basically the collision will be lesser as well. So we need more energy in order for successful collision to be happen. The molecule must collide in the n orientation that can lead to a rearrangement of the atom. Okay, this one I will show figure on how it happened. Okay, this is what I've been saying, that orientation is very important. Right, look at this one. Okay, this is how CH2 plus HCl produce H3 CH2Cl. Okay, so now you have this one. Let's say this is CH2C, the black one is C, this is H2, CH2. Now you react with HCl, H and Cl. Okay, so now the orientation of Cl pointed to the double bond. This is meaning that their orientation is different, and this one can break the Cl can break the double bond, alright, in order to produce more reaction of CH3 and CH2Cl, alright. But somehow, let's say this one, HCl, where H is actually pointed to the double bond, it couldn't make up a reaction because H with double bond couldn't break the double bond. So that's meaning wrong orientation wouldn't bring you any successful collision. Right, and then how about if we have HCl with a H here, okay? Right, so okay, sorry, this is H, this is Cl, this is HCl. Alright, when you have H react to the, it's not pointed to the right angle of the H2, okay, so it couldn't break the bond here or form any rearrange, it couldn't be rearranged, correct, so that's why there is no collision happen here. But somehow if you have this one, Cl to the H, okay, Cl here, H to the H, sorry, okay, H to the H here, when they're attacked to each other, they can rearrange to produce CH3 over here, so that's why you see this H and H. But somehow the double bond here is not being broken. Okay, so that's why it's still wrong. Okay, it couldn't make a new rearrangement. So orientation is very important. Okay, what you need to know here is the larger the temperature here, when you have the higher temperature here, basically the smaller the negative term will be. But the smaller the negative term, the larger value of, you can apply the E exponent x. Therefore, increase the temperature will increase the reaction rate. Okay, key value. Right, so EA, we know that this is activation energy. This is the minimum. EA being defined as a minimum energy required to initiate a chemical reaction. So the molecule, before any collision will be happening, the molecule must possess a minimum amount of energy to react. Why? Okay, because number one, there must be bond broken must be happen, and then number two, bond breakage require energy. So that's why if you don't have the minimum energy, then how you're going to break the bond? Okay, right. So this is how to determine the activation energy via graphically. Right. So we know that for Arrhenius equation, when we have ln K, you versus 1 over T become the x, and then your slope is negative. Slope represent EA over R, and your T represent ln A. Okay, so you compare with y is equal to mx plus c again. So your y is ln K, just put it in here. M is EA over R minus, because of the slope is negative, x is 1 over T plus ln A, which is positive. Alright. Okay. So next, from that we can get ln K is equal to EA over R times 1T plus A just now. Okay, but when we have two different kind of K value, let's say at different temperature, you have to compare and combine them together, where ln K2 over K1 or final over initial is equal to EA over R. This has been simplified where the negative has been omitted. Okay, EA over R times by 1 T1 minus T2. This is initial, this is T final. Okay. So this is an example how to solve that that formula. For example, the activation energy of first order reaction is 50.2. Activation energy is mean that this is EA. EA is given. Okay, at what temperature will the rate constant double? Okay, so we want to know T. Okay, at what temperature? So you can use this formula. Ln K2 over K1 is equal to EA over R. You know value of R. Okay, 1 over T minus 1 over T2. Okay, so now okay, you can convert this into joule, into mole, joule over mole, because you're going to use the same unit, joule over mole per K. Alright, so you convert into 50,200 joule. Right. Okay, it being said that rate constant will be double. So we can say that K2 now is being double. So you can put 2K1 over K1. You can also put, because why we put K1 here, we want to cancel it. We want to cancel it, okay? If you put K2 over K1, you'll be confused here. So you assume first that their value is the same, but it's been doubled up. Alright, so that's why you put K1 over K1, but we have 2K1. Okay, so EA is known now, R is known. Alright, so 1 over T1 is we mentioned 25, so 25 plus 273, you got 298. Over T2, you want to find your T2, is unknown. Right, so now you solve that one. Ln 2 is equal to that one, 6038K over times by this one. Okay, solve everything, so you got 1 over T2. Okay, so T2 is equal to 308 Kelvin. Make sure you answer in Kelvin. Okay, there are more exercise to answer. So answer is given here, just you need to solve the problem.